Hey everybody, as I mentioned, Snow Talk today is going to come in two pieces. The first piece will be mainly just for this weekend, focusing on that, and then I'll do longer term, covering Thanksgiving and everything later on. Probably after I get done with the 5:30 news tonight, I'll get a chance to knock that out. So make sure to check back for part two. All right, let's start with temperatures at the moment. 60 outside. It's really nice out there. We actually have a few clouds streaming overhead. These are not rain-producing clouds. That may slow the temperature down across Indiana, but it's a cold front actually that is moving through. This was a dry front yesterday, and that's the reason why that our temperatures really didn't change much. It just got rid of the moisture in the air for the most part. This is the one, though, that is going to knock the temperature down. So it is going to be colder tonight compared to this morning. Then we get ready for our system for the weekend. The energy is now onshore and is getting sampled today, and something that didn't really happen yesterday. So we're starting to see some issues with timing showing up now with this, and I think that's going to be the biggest catalyst. Yes, moisture is important when it comes to the typical how quickly does the cold air catch up to the moisture and turn it over to snow showers. We know that drill. But timing is going to play a big role in that, and that's what I've noticed on the midday data so far. And this is going to be a fast-moving system right to the east within about a 48-hour period. So what I'm going to do is show you some of the short-range models that we have in-house, and I'll show you some other data too, and hopefully explain what I am looking at first off and what I think is most likely to happen. Alright, so let's begin with our high resolution RPM model that we have. First off, for tonight, I'll start there. It is going to be colder tonight, as I mentioned, into the 30s. Tomorrow, not bad. I think we'll make it into the mid-50s, depending on how quickly we get the clouds streaming in. Because, again, that's a fast-moving system that's in the northern Rockies right now. It's going to be here for this weekend. So it's going to stream in a cirrus deck of clouds real fast right over us. So how quickly they get here determines how warm we get for Friday. But here's where we get into problems. The last couple of runs of the system have tried to really deepen the pressure on this low. And it's a pretty potent little vort that comes through the Ohio Valley. But because you deepen the low, it's good and bad. Good in the idea, if you're a snow lover, that it's going to really pump in a lot of cold air behind it, and rapidly. Bad in the idea that it has an opposite effect ahead of it. It can warm you up. And this is what our short-range RPM is having at 3 o'clock Saturday, nearing 60 degrees, with a band of rain moving in, a narrow band of rain. So when you get up to 60, well, we got that much further to fall to get to the point for the atmosphere to support anything frozen. As we head into the not as great resolution, this is the 12K RPM, so it's not as highly defined as the 4K is. 4K can only go out to that point of the afternoon, about 3 o'clock on Saturday. So I'm switching over now to the 12K version, and you'll see it's similar, obviously. Warmer ahead of it, rain band pushes in. We do see a significant drop when that rain band hits. That's the front. And we go from 58 to 44 in about 90 minutes. That's significant. Look at Bedford. You guys are 39. And then we keep dropping. 36 is usually the magic number for 36, 37 is usually the magic number to see rain go over to snow. And we really don't get to that level when we have moisture around. But Eastern Kentucky does. Yay, Eastern Kentucky. But by the time we do, there's not much left. And then East Kentucky gets all the benefit. And then we just get plain cold into the 20s. So the RPM model is betting on the idea of a deeper pressure, faster system, in other words. And that would allow us to get a good warm-up ahead of it to where most of it will fall as rain. And by the time we try to get to that point to support snow, we lose a lot of the deeper moisture in the atmosphere. And even flurries would be hard-pressed to happen. All right, so that's RPM. Now I'll switch to the NAM model. This is the 12K version. I'll show you the higher resolution in a second. This is the 12K version. Let's speed it up to Saturday morning. Start off in the 30s. By 3:30. Now notice it's slower. This model is compared to the RPM. You know, the RPM had the band of rain already on us at 3 o'clock. Now the NAM, as it's slower. Yes, we do warm up in the 50s, but because it's slower, we have the nighttime in our favor. We get closer to sunset. So as we approach sunset, we drop to 47. We start to see some snowflakes mixed in the northern half, and goes over to a brief period of snow flurries, snow showers throughout the evening. better chance East Kentucky, and then it just turns cold again by early on Sunday. In fact, it even tries to, it says accumulating snow, but this would be trace amounts. I mean, the ground's too warm. You guys know that. But a trace amount is probably what would be registered if you go by the ENAM, and that looks to be the worst case scenario. It's just not enough moisture in the atmosphere for a long enough duration and deep enough cold air to benefit. Unlike our friends to the north, like Indianapolis, that may get a chance to do so, our chances look a lot lower for that. But I know, I'm not trying to make a big deal about flurries. I'm really not. But it's the first flakes of the season, and you guys get excited about it just as much as I do. So for you snow lovers, this is really for you, and that's why I really want to analyze this and show you what we're looking at. All right, so let's show you the high resolution of the NAM. It doesn't even give us any changeover at all. Just a band of rain, snow, even north of Indianapolis. Let me show you a better way to look at this. It's soundings from the Buffget. All right, you remember this from last year, I'm sure. Here's ground level. Here's up here where the airplanes fly. All right, so you're looking up. These are the winds, mostly a southwest wind. What you're looking at is the freezing line in the atmosphere. It's a diagonal line. This is the freezing line. The red line is temperature. The green line is moisture. The closer the red and the green are together, very, very moist atmosphere. The further they are apart, the drier the atmosphere. And you can see at 1 o'clock in the afternoon on Saturday, very moist column. I mean, it's a pretty moist column, but look where a lot of the moisture is falling. Here is the freezing point. This portion of it is to the right of the 0 degree line. That means, yes, that's a snowflake that's falling, and then it's a raindrop. All right, that's why it says over here, raindrop. All right, so let's advance it. Here's 4 o'clock in the afternoon. We get colder. We're getting, that red line is getting closer to the 0 line here at the ground level. But look what happens aloft. We begin the drying out process. So yes, we're beginning to lose a lot of the moisture, but we are getting less and less. It's to the right of the 0. And then by the time we really get to the point where we can support a snowflake and snow flurries, say 6 o'clock in the evening, we can do that. We even have a little bit of dry air at the surface to work with a little bit of dynamic cooling. But it's still pretty dry aloft. Now, the one thing that's interesting, there is still some moisture that is above our heads. Now, I have seen this many times before where you're still able to get some snow flurries to fall out of that. And that would be it, snow flurries. So why the high resolution NAM is not showing snow flurries on the actual map, the sounding does support that possibility. It is a little dry at the ground level, but not enough for me to say, no, there's no way there's going to be snowflakes. I can see that. I can see that on this particular version. All right, here's GFS, brought to you by our friends over at Weather Bell. Its timing is about close to the 2 o'clock time frame, so a little slower like the NAM was, with a rain band mainly west, snow on the backside, and by the time we get into the late afternoon, it does catch up and gives us a change over to some snow showers for Saturday night. By all means, the GFS is the most dramatic here with the rapid cooling and the amount of moisture available. But here's a bummer. I love the Schreff model. It's one of my favorites this time of the year. Yesterday it was aiming more toward the blue line, which is snow, for Saturday night being the more dominant precipitation type. Well, today it is coming in with green being more dominant than the snow. So it's betting more on the rain, but it's still got the snow on there at least, but it's betting on, basically it says here, a 20% chance for rain and a 15% chance it'll be snow. So what do I think? Speed is going to be crucial on this weekend. And I hate to make such a big deal, such a minor thing, but speed's a big deal. If it waits and pushes in the rain band, say 3 or 4 o'clock, we have a better chance to get a decent snow shower right at sunset. If the rain band pushes in here too quick, shortly after midday, it's going to be all rain, and we'll be lucky if we have any moisture left to produce snowflakes Saturday night. The cold will be the big story. So I'm pretty sure when I do the blog update here on the confidence meter of anything wintry is going to have to be lowered based on this data today. I have to go with what I see until I get better data on this and trend it. All right, guys? So it's not that disappointing. I mean, you're going from the possibility of snow flurries to nothing. It's not like the end of the world, so don't give me that look. You give me that look. But it's not off the table completely. All right? Not off the table completely. I'm going to leave it on there. I'm just going to ease back a little bit because I have to go with what the data shows until the storm system gets closer. And that's the way meteorology works, guys. All right. I'll have part 2 later tonight. Talk to you then.